So yeah, I think I'm live. So okay, it's very interesting. My, I charged this particular person. So I had an idea. I could just continue this one. Well, there's a lot to list here. And this is, I can say this is probably a short, short video. Or no, it's like short. But this is a, this is a video that, sorry, this is a state that, I, ouch, to just, these MI6 documents. So I just do exactly like the reason why I actually chose content history. Content to stay in the first place. So in the right channel that I am. Okay. Thank you very much. So yeah, I did present the engineering section. Uh, I'm just doing a bit of a clip for starts. Uh, So once a tag is for people to be able to tag can be used in your content. That's pretty very um, AI, AI, uh, G, uh, yeah. The rest is that's one description language. English. It's English. I only speak English. So apparently nobody told me this something that is this stress. And I was having serious like very serious epic prior like the last night. So it's tiring, but I'm here so I can't I really can't. I did this. I told myself that I am going to hold myself accountable to this platform. Yeah, I listen to music a lot. That explains why that explains why there is music in the channel together because people listen to me. So let's go with that. I don't know if I'll get rest now for this. So I'm still contemplating to or not. But yeah. I don't think it's I don't think it's so I think all my voice I don't think it's that please you learn no matter your current job. I can like for myself so I mean which still bring us to why did I create this channel to myself account while out there. Like, so I don't see yeah, so I'm like this. And yeah, I'm an ADHD, yeah, so a lot of my complexity. I just, I might be doing something now, and I'm jumping. So, sorry about that. Yeah, so let's get the party started. Yeah, let's get the party started. Oh yeah, I have, I have something very, it's private for the chest. So yeah, I don't know if you can see my. I'm doing that. Let's get you good. No matter your condition. Forget where you know something must go before something come. It is what we do. Oh, Jesus Christ. That should not be your fault. Very sorry. Sorry to wait. No, sorry. Yeah, there's also something else that should help. That's something else. Once the Narara, it's my idol, you fuck. So many good, but you man don't. But not like I'm good. Even Jesus Christ, you know. Then I'm focused. You know, you beat everybody. Come on, my man. Oh, so yeah, I think it's peace out. Let me see what it is. So yeah. Yeah, so this how's the word? So, I don't know why. I think you want to increase. Yeah, let me pause it. Let me pause it. I think you want to. You want to increase it to 140 because I genuinely don't know why YouTube keep torturing it to 750. So yeah, now it is clear you can actually follow and see everything that I'm doing. I don't know. I don't know if you can see it. It is now better. It is like it is clear to get to 140. What YouTube was giving. Just don't know why YouTube keep torturing it to 750. So yeah, now it is clear you can. Yeah. Okay. So yeah, like I said, yeah, this one. So I built an MCP server actually. And how I enjoy to do this is because as an AI engineer, you will also learn. to understand how to use AI to. That is why this article. If I was rich, I would be using Claude, and I know it'd be like, oh, I can use Claude without being rich. Yeah, I understand, but I'm on Google Pro too, so it's not like I can do both of them. Yeah, one is charging dollar, the other one is charging. Naira. So I think I do the maths. Just in case one of us misses, yeah, sorry, just in case one of us misses pay for our Claude, Claude, what is it called? We might do it, yeah, Claude subscription. Also, I'm starving. I'm starving, so I need to. But this is not why you are here. I'm going to give us a very one. But why are we? Why is what are we doing today? Today we are. Today we are going to. Oh, sorry. Today we are going to. Uh, setting some. Yeah. I don't know how this. I don't know how this works. Okay, yeah, this is better. Yeah, it's better. So let me see. Let me see what you are all seeing. Let me see what you are all seeing. So I've been spamming so I've been spamming so yeah. Now let's get to the nitty gritty. But I had everything. I had what are they called? I heard these guys are doing. I heard these guys are doing a demo today. Yeah, Nvidia. Okay, they have a keynote section. So let's check it out. See, are they speaking English?
Is disaggregated and distributed. Networking becomes the problem. Therefore, we have to move the data around as fast as possible between the CPU cores and between the CPU and the storage, the CPU and the GPU. The bandwidth around the system and inside the CPU core has to be utterly world class. This is the first CPU that's been built a long time
Agentic AI.
that is literally at reticle limits
AI.
with a fabric that connects all of the CPU cores that is speed of light. 3.6 terabytes per second.
Wow.
No chiplet tax, no chip boundary crossings, because we need to have everything, because the CPU cores are talking to each other with extremely high bandwidth. They're not rented core per core per core, they're all working together. The cross-sectional bandwidth of Vera is off the charts. It's the first one to be PCI Express Gen 6. It is also the first one to have LPDDR's DDR5 with 1.2 terabytes per second. 2 to 3 times the bandwidth of the highest performance CPUs on the outside, 3 times the bandwidth on the inside. The bandwidth per core and bandwidth period is world class. Now remember, I showed you earlier, the number of CPU cores, the number of CPUs is going to be quite high. And the reason for that is very simple. We created CPUs for humans in the past. And humans, there are only 1 billion of us. There will be billions of agents. And these agents
I'm very
are
sure.
going to be using the CPUs with very little patience because the cost of the GPU they sit next to is too high. And therefore, too valuable, too precious. Therefore, these CPUs are going to be both performant, but they also have to be extremely energy efficient so that we can cram as much CPU into the factory without taking away power from the token generation, which we know is how we make money. These four properties, instructions per clock or single threaded performance, bandwidth per core, the total bandwidth around the chip and inside the chip, and energy efficiency defines Vera. It is absolutely world class. When you compare it to the highest performance x86, it is just off the charts. When you compare it in real single threaded performance, it's off the charts. It is incredible to be able to deliver 5% improvement on CPUs. It is incredible to be able to deliver 10%. But this kind of performance speed up is just unheard of. This is Nvidia Vera. What do you think?
Nvidia Vera, agentic chip.
Let's take a look. Agentic AI changes the role of the CPU. The CPU is now the conductor, and the GPU is the orchestra. Traditional CPUs were built for a different era, maximizing cores per socket. Slice them up, virtualize, rent by the hour. In the age of agents, the CPU is now a bottleneck to GPU utilization, directly affecting token throughput, latency, and user experience. NVIDIA Vera is the CPU built for the agentic loop, combining NVIDIA's custom data center CPU
So this is why you
with a
need
scalable coherency fabric
focus on
with the right balance of performance cores and
AI
data width to
generation.
maximize
But
AI
as
factory health.
much as
At the heart of Vera is the NVIDIA Olympus
software engineering
built
is
for modern
getting
data center workloads. Branch
the
heavy
fundamental
Python
skill is still precious like man.
and
Because
sandbox
it's going
code
to
execution.
agent that is going to
Each
utilize
core
this. So
is
Python
tuned for
code,
throughput. A neural branch predictor evaluating 2
Python
million branches per cycle. 10-wide decode engine brings in more work each cycle. A large out-of-order engine keeps instructions moving. Advanced prefetchers with a novel graph engine anticipating the next data. But fast cores only matter when data arrives correctly and on time. Vera is the first CPU to use LPDDR5X memory while correcting multiple errors simultaneously without compromising bandwidth.
So there's
Vera
basically
achieves
just
40% lower
yeah,
memory
like okay,
latency
so
versus
yeah,
keeping cores very
voice
high through retrieval, analytics, and sandbox execution. NVIDIA's second 88 Olympus cores, 88 Olympus cores on a
out.
monolithic mesh.
So Google did their keynote here, and they're all about agents, agentic AI, agentic. Last year it was AI, to the point that they had this thing and AI counter. So this year is agent. Now this guy is building chips specifically for agents. Usually these chips are not even entirely expensive. Okay, now you're putting sandbox to it. It are not like, or due to capitalism and war against time, I mean race against time. I don't know how to put the word. You know when there are like multiple countries. Yeah, like for example, space race. So basically it's just agentic race. What we're dealing with here is what we're dealing with here is classic case of capitalism make politics. But overall, yeah, this is like going to be one of the best things that ever happened to mankind. Because if at first, when Terminator seems like something that is going to come in, say, the next 100 years. But with the way things are going and how much processing power is getting increased, we might have Terminator before the end of, let's see, 28, yeah, 2028. So I don't want to like overestimate, underestimate. Yeah, I'm betting on 2028. Yeah, let's listen.
From external CPU x86 into Grace Blackwell. That transition was extremely dangerous, but we did it with incredible execution. Now Grace is literally synonymous with Grace Blackwell.
Yeah, 1 minute.
When people say Blackwell, they think Grace Blackwell because it is utterly now everywhere. Every company's software stack has been optimized for it. Everybody's security stack has been optimized for it. And now here comes Vera. I'm super excited about that. Now look at some of the performance numbers.
Yeah, so
Speed ups is one thing. It is extremely hard to speed up SQL.
I don't know if I'm getting cooked.
SQL, the most famous domain-specific language, DSL, that has ever been created. Before SQL, before CUDA, there was SQL. Before OpenGL, there was SQL, invented by IBM. Today, it is the structured database engine of the planet. Everybody uses SQL. This is SQL running 3 times faster, not 10% faster, not 25% faster, 10 times faster, 3 times faster. Incredible. This is real time.
Why does that sound sarcastic?
Real time stream processing. Remember,
He said
your AI is going to be.
He said not 10 times faster,
Your
not
AI
20
is
times
going to be
faster,
watching
3 times
telemetry,
faster. Like,
especially
sounds sarcastic actually.
inside a stock exchange. You're going to be looking for telemetry continuously. The burst of data that's coming in goes into a CPU. This is Vera CPU running real-time stream processing for New York Stock Exchange. Lynn Martin, the president of New York Stock Exchange, has been so gracious to partner with us. This system is run all over the world in real-time stream processing. Vera CPU 6 times, all because of the bandwidth, the single threaded instruction execution, bandwidth inside between the Vera is completely revolutionary. That's Vera. X factors is something you talk about when you're talking about GPUs. It is quite rare that somebody talks about X factors on real workload that is associated with CPU. So I'm so proud of the team. You guys did such a great job. We have an extraordinary roadmap coming. But what's really exciting is almost everybody is supporting Vera. They're as excited as we are. This is Vera opening up. It's opened up a brand new market. Agents is a new workload.
The door or the gates to quantum computing.
We need CPUs for agents, agentic systems. The properties are different. Why would the old CPUs be the same? We are building millions and millions of errors.
By the way, this guy is
millions of errors
for gamers.
To go to market with us,
no,
gamers, ODMs and computer makers, all the OEMs, and you can see the early adopters. The early adopters are the agentic companies. This is the beginning of a new market, a market that never existed before. It's not going to take away from the old markets, but this is a new market. CPU for agents. And this market will surely be larger than the last. And the reason for that is because there'll be a lot more agents than there are people, and then the agents are very impatient. So NVIDIA, Vera, CPU. Thank you. this is the most important slide, really. This is the takeaway. The takeaway here is that this is the application pattern. This is the computing pattern of the next decade. Agents, harnesses, orchestrating large language models. Every company will run it.
Apparently.
Every company will be an agent company.
Mhm.
Every company will have agents running
I mean,
inside.
The thing is,
Every
it's
company
not even
will
like
see that agents
it's
will
saying
need its
it's saying the
operating system.
absolute.
Every company is asking us, how do we run agents safely? How do we build agents for our own workloads? And so we have the Nvidia Agent Toolkit for Enterprise AI. You've seen me build this in plain sight.
Ow!
Almost everything that Nvidia does, as you know, at every GTC, if you go back and look at my GTC 5 years ago or 10 years ago, you will see today.
Are you guys now software
This
company?
you've seen me talking about for several years now because we've been building for this moment. There are
This
four things
React
that
now.
companies
This is like
do in order
React.
to build agents as a service
You
or
said in
build
the
agents
context,
to operate. The first thing
observe,
you need is you need models.
reason and act.
Of course, large language models. The smarter, the better. The cheaper, the better. The faster, the better. The second is you need a harness to orchestrate the whole thing.
And this
The
guy is now
third,
software company.
these models want to use tools, and these tools come with it skills. Those are going to be amazing tools for the agents in the future. And then lastly, you need a runtime. You need the operating system that holds it all together. This is the NVIDIA toolkit for agents. It includes models that you can modify. NVIDIA's world-class open models, and I'm going to show you more. You could run agents from anybody. You could run Cloud Code, incredible agent, Codex, incredible agent. You could run it inside this harness of open shell, which will be highly secure for your inside the enterprise. The shell protects the agent, keeps it grounded in security policies. Privacy is protected. Its rights and privileges are given. Its identity is protected. And so this open shell is being adopted all over the world. NVIDIA open shell is open source. You're going to see so many companies adopt it. Red Hat, Canonical, Microsoft. It's going to be adopted everywhere. This is this is the runtime. And this runtime is only optimized for the NVIDIA AI platform, which is everywhere. So you can run OpenShell in any cloud.
Yeah, the reason why I'm here is
and
because
even on device.
the AI
So
ecosystem is
you have
yeah, if you sleep and wake up, yeah, hearing AI. You sleep and wake up, you're hearing AI that. So I mean,
as is, or you have
the best to just get up to
This
speed
be
is to
open
follow
cloud.
up with
Hermes,
these people.
another incredible
Content.
harness. These agentic harnesses can now run on-prem.
I don't guess. I don't think I can
So
guess.
four things, and this represents the operating system of the modern enterprise.
I genuinely don't even know. I guess suit. I'm sorry. I mean,
One of my favorite use cases of agents.
Let me search if I can guess.
It is the single most important thing that NVIDIA does.
Is not.
And so, of course, we have to partner with Cadence to build super agent, a chip design super agent. It is orchestrated by Codex by code. It has RTL and architecture diagrams or schematics or specifications as input and whatever you need to fix. And together we created some super agents that are optimized for the NVIDIA runtime with Nemotron. And let's take a look. It's really incredible. Cadence and NVIDIA are partnering to build chip design agents. Hundreds of thousands of NVIDIA chips come together to make the AI factories that power the world's frontier AI model. Design
They said yes, if I guess
they run in is one of the hardest engineering challenges. Trillions of transistors, three-dimensional circuits, microscopic scale. Every gate Every wire, synchronized to picosecond, must work in perfect harmony with no margin for error. Physical types of flow and too costly. So engineers work in the digital realm. Each chip begins as a set of architectural specifications, then translated into RTL, the language of chip design. RTL must be verified in simulation. A single bug can delay a chip by months. At Nvidia, thousands of engineers, billions of compute hours per year, millions of tests written, run, and debugged. A cycle that takes weeks. To compress this cycle, Cadence and Nvidia built a design verification.
I want to continue.
Codex orchestrates the process. Cadence launches the RTL verification, powered by Nematron and secured by NVIDIA OpenShift. Calling on expert sub-agents in RTL generation, test bench creation, regression testing, and debug. The system drives itself. The chip stack agents run hundreds of simulations with Cadence Xcelium, formal verification with Jasper, design flaws revealed, bugs in the code fixed. What once took weeks now takes hours. Verification cycles over 40 times faster. Together, Cadence are reinventing chip design with AI agents. From weeks to hours, from weeks to hours, from weeks to hours. NVIDIA has thousands of chip designers. We are going to hire hundreds of thousands of Cadence super agents that work with us so that we can accelerate our company, so that we can be even more ambitious, create even more amazing things, run even faster. You saw earlier that the toolkit with models, harness, tools. The tools in this case are Cadence simulators and verifiers, formal verification systems. It is the reason why we're working with Cadence so hard to accelerate all of their tools on CUDA, because the agents are impatient. The agents want the answer immediately. And so models, harnesses, accelerated CUDA, accelerated libraries and tools, and then the runtime. What you saw just now is all of that coming together. Now, one of the things that it starts with is a great model that Cadence could modify and tune to be expert at the Cadence workflow, at the Cadence expertise, so that they could create super agents that are proprietary to Cadence with their proprietary knowledge. They have to start with an excellent model. We call it Nematron. NVIDIA is dedicated to build open models for the world so that all of you, all of us, could create our own agents. Today, we're announcing the Nematron 3 Ultra. Yep, our next open model. And it is smart.
Nemo, Nvidia agents.
The Nematron models not only give you the model,
There's a lot.
we give you all the data that we use to train the model. And because we have a coalition of incredible partners, you can see all of our partners down here. We work together, contribute data to each other. Nematron is trained on one of the largest suites of long-running reasoning models, long-running task-solving, tool-using data sets in the world. Because of all of our great partnerships, all of this from the
When
model
did this guy turn to myself? I would
and the data made completely available to you. This is open model at its best. The best open model system policies in the world. Simple goal is that you can take all of it and add to it, make it even better, make it yours. Nematron 3 Ultra is 5 times faster. This is the world's first model based on a hybrid architecture of SSM, state space models, with mixture of experts. The architecture is incredibly fast. We made it fast so that you could think fast. When you think fast, you could think longer at the same cost. So 5 times
They're not
faster.
conceding others.
It is also
They're just focused.
30% cheaper, 30% lower cost to run in total flops, total inference time, than even the most cost-effective in the world.
But yeah,
We're comparing against the world's best open models. Frontier Smart. 5 times faster. 34, 30,
We can. Okay. Start. That. Start. Sorry. Oh, I got advice. Websites. So just in case I don't really. Guy. Sure. I'm exhausted. I can't. Let me see if I can continue this. If I can continue, I'm just going to go and crash. So there's change LLM. There's adding field. Let me get it. How does work? Okay, swap a field. Sure. Select agents. Get another thing is like SEO. Crash. I like Python. But I'm not using Python anymore. I'm not using Python. So that makes me nervous. So does the even out? So, uh, and kind of like, so it's I, yes, I think I can. I can. Yeah. See, what, what, what that? The brain is tired. Uh-huh. I mean, you know, how it's copying somewhere. So, all that's just not that like what I'm I'm yet to see. You know what? I'm going to the classroom instead. Because I am not the one that going to get stressed. I don't like stress. I don't talk that about stress. Guys, stressing me. I cannot. I, actually I have silent. Uh, yeah, I remember a keyboard. Now I remember a keyboard. Yeah, I got it. Yeah, that yeah, that so, to watch. Ìjó san ní adé ò ṣe fi sára ẹ̀yà rẹ̀ ṣe. Ìrora ẹ̀jẹ̀ ká. Ẹ jẹ́ ká máa jó. Ó yẹ ká máa jó. Ìbí mi ká máa jó lọ. Ìbí mi ká máa ṣe lọ. Ká sì mú oyè aládàsọ. Ká sì mú oyè aládàsọ. Adùn má má dẹ̀rẹ̀kẹ́ o. Yádùmọ̀ yádùmọ̀. Ẹ jẹ́ ká máa jó lọ. Ó yẹ ká máa jó ní ìtọ́lẹ̀. Àní ó yẹ ká máa ṣe lọ. Ìbò mi ó yẹ ká máa ṣe lọ. Ká ṣe mú oyè aládàsọ. Ká ṣe mú oyè aládàsọ. Adùn má má dẹ̀rẹ̀kẹ́ o. Yádùmọ̀ yádùmọ̀. Má má dẹ̀rẹ̀kẹ́ o. Yádùmọ̀ yádùmọ̀. Ìyẹ́fà. Yádùmọ̀ yádùmọ̀. Adùn má má dẹ̀rẹ̀kẹ́ o. Yádùmọ̀ yádùmọ̀. Yádùmọ̀ yádùmọ̀. Adùn má má dẹ̀rẹ̀kẹ́ o. Yádùmọ̀ yádùmọ̀. Adùn má má dẹ̀rẹ̀kẹ́. Yádùmọ̀. Adùn má má dẹ̀rẹ̀kẹ́ o. Yádùmọ̀ yádùmọ̀. Yeah, that's
Nọ́mbà tí yóò gbọ́dọ̀ jẹ́ lọ́mọ àná yẹn. Báńkà tí yóò gbọ́dọ̀ jẹ́ lọ́mọ àná yẹn.
that's actually
Bá mi bí ló fọwọ́ sọ̀rọ̀.
actually
Ó
very
ti ń fọwọ́ sọ̀rọ̀ lójú bá mi bí ó ti dájú pé èmi nìkan ló lẹ́yìn ò ìwọ kò lè gbọ́.
accurate.
Èmi nìkan ló lè gbọ́ ò ìwọ kò lè mọ̀. Èmi nìkan ló lẹ́yìn ò ìwọ kò lè gbọ́. Èmi nìkan ló lè gbọ́ ò ìwọ kò lè mọ̀. Torí bẹ́ẹ̀, àmúrògodo múrògodo múrògodo àmúràbàtì múràbàtì múràbàtì. Onídìrí bá mi lálejò wọ́n ti ṣèyí sí. Kìí jẹyán kìí jẹ̀rẹsì abọ́mi òwúyọ́. Omi lákẹ́ omi sóró òjò wẹ́líwẹ́lí. Èyí àrà wọ́n pẹ́lẹ́. Èdè jọjọ olùkọ́ni sáńpọ̀.
Survive. Very fast. Vamos sonhar.
Múrògodo 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 ayé àmúràbàtì múràbàtì múràbàtì wá. Onídìrí bá mi lálejò wọ́n ti ṣèyí sí. Kìí jẹyán kìí jẹ̀rẹsì abọ́mi òwúyọ́. Omi lákẹ́ omi sóró òjò wẹ́líwẹ́lí. Èyí àrà pẹ́lẹ́. Olùkọ́ni sáńpọ̀. Èèpà iná pìtì iná pẹlẹbẹ. Alẹ́ òní ayàtọ̀ ìdájí òní ṣe é kó kájọ máa yá ká jẹ ayọ̀.
Yeah.
Iná pìtì iná pẹlẹbẹ. Alẹ́ òní ayàtọ̀ ìdájí òní ṣe é kó kájọ máa yá ká jẹ ayọ̀. Bóyá ẹgbẹ́
Yeah. Um, that to swap. These is how you.
PlayStation.
This is very.
Mo dúpẹ́ oníbù ọ̀rẹ́ bàbá
This
gbọ́
is very
ẹ̀.
interactive, right? So now it changes.
PlayStation.
Now it changes
Mo
this
dúpẹ́ oníbù ọ̀rẹ́ bàbá gbọ́ ẹ̀.
a local your local lava. Now check. Five for I don't think there is any. Say like that be like ba. You think that drunk.
Appreciation. Oníbù ọ̀rẹ́ bàbá gbọ́ ẹ̀.
Now swag out.
PlayStation.
Swag that sorry.
Ènìyàn kan lọ́lọ́run nínú. Ènìyàn kan ènìyàn kan lọ́lọ́run nínú. Ènìyàn kan nínú.
See why it's sorry. Like fuck. I don't want that.
Appreciation.
Like five. I don't want that. So now like what is that? What's my
Appreciation.
yeah, I said I'm not going to that. I'm not like that. But that aside, did it swap that nothing of
Ilẹ̀ ilé mi ẹ̀dá bẹ́ẹ̀ lọ́gà ẹni àkọsílẹ̀ bẹ́ẹ̀ lọ́ ẹ̀dá èmi bẹ́ẹ̀.
So I just okay, there's that. I was thinking, I see something easier that I was obviously, obviously, I'm obviously, I don't know, in respect to that, let me start with that. Extra spread. Oh, so if I swap, so if I swap, so it's eight. I think, yeah, strength more like but to show you guys what I'm talking about, Shashank, my whole MCP, I've learned and went deep into this that I'm showing my heart, making secrets. Okay, so my whole MCP, I'll do that. Oh no, where's MCP? Where's the DK? Yes, I play agents. And I still have coaches. But then that's fine. Let me know. I can see. I can Right. It's fine. But no, where's my is quickly that job? Is it like it's fine. I've not really suggest it out. Jesus Christ, if anyone laugh, just like and subscribe. Just, yeah, like and subscribe. We have a lot of learning. We have a lot to yeah, let's keep around. Let's keep around. Ah, my God. Ayé retí ẹlẹ́yà mi o, wọ́n retí ẹlẹ́yà mi o lójoojúmọ́. Wọ́n tún kóra wọn ọjọ́ wo láti gbẹ̀gàn mi. Wọ́n ní mi ò mọ̀júlé àdúrà lójoojúmọ́. Wọ́n ní mi lọ́nà ilé àdúrà wọn máa ń gbẹ̀gàn mi. Wá So, I just realized that it's an outfit. Not just it's a single. So it is search and cap. Like it's like who would get it? This is fast man. Ayé ń retí ẹlẹ́yà mi o, wọ́n ń retí ẹlẹ́yà mi o, lọ́jọ́ I think it's time for it. Wọ́n ti kọ́ra wọn jọ wọ́n láti gbẹ̀gbọ́n. You know I spoke about what I just passed wọ́n ní mi lọ́nà last lesson. Ẹ̀gbọ́n mi wá lọ tuntun ti so odò bí yìí lọ gbèsè ẹ̀wá wọ́n ní ẹ̀yìn bàbá mi dàgbọ̀ tàbí àpẹẹsẹ èmi náà bá wí ẹ̀ ọ̀dọ́ ṣọ́ wàá máa bọ̀ bí nìkan máa jẹ́ kó.